Chapter 6, Section 1, Solving Systems by Graphing. A system of linear equations is a group of two or more linear equations that have the same variables. The solution to a system of linear equations is any ordered pair that makes all of the equations in the system true. Remember that if all of the equations for an equation to be true, you have to wind up with an identity like 3 equals 3 or 4 equals 4, some true statement of equality. Systems of equations can be solved in more than one way. To find the solution of a system by graphing, you graph each linear equation in the same coordinate plane and find the intersection point if there is one. So intersection means the point where the two lines cross each other. So to solve by graphing, notice that I said there's more than one way, and that's what we're going to spend the next several days talking about. But for graphing, you're going to go ahead and you're going to graph both of them on the same coordinate plane, so in the same graph. And you're going to find the point where the two lines cross each other. That ordered pair is going to be your answer. This first example says, what is the solution of the system? Use a graph. So they give us the two equations, y equals 2x minus 1 and y equals 4x minus 7. Both of these equations, it's very nice, they're both in slope-intercept form. So to graph the first equation, y equals 2x minus 1, I'm going to start with a point on the y-axis at -1, and I'm going to count my slope 2, which means go up 2 to the right 1, up to 2 to the right 1, and we wind up with this line right here. The second equation is y equals 4x minus 7. I'm going to use the same coordinate plane. This time I'm going to start at -7 on the y-axis, that's my y-intercept, and then I'm going to count my slope from there. My slope in this case is 4. Which means I'm going to go up 4 to the right 1, up 4 to the right 1 units, and go ahead and plot this line right here. Notice my two lines, they're two different lines, they intersect right here, and that point where they intersect is at the ordered pair 3, 5. What this means is that this graph shows us that these two lines have the same point or are both true at the point 3, 5. What I'm going to do and what you have to do, there are no ifs, ands, or buts. You have to prove and check your answer to make sure that this ordered pair is correct, the correct solution for the system. How you do that is you go back to both of your equations, y equals 2x minus 1 and y equals 4x minus 7. You plug in 3 for x and 5 for y, and you make sure that you wind up with an identity, or you make sure that you wind up with a true statement. So I'm going to go ahead and show you. The ordered pair 3, 5 will be a solution to both equations if it is a solution to the system. So to be a solution to the system, to the whole thing, you have to be a solution to each part. To do that, like I said before, I'm going to go ahead and, for the first equation, I'm going to plug in 5 equals 2 times 3 minus 1. Well, 2 times 3 is 6, so I have 5 equals 6 minus 1. 6 minus 1 is 5, so 5 equals 5 is a true statement. It does work for that first equation. I'm not done checking my answer yet, though. Now I need to plug in 3 for x and 5 for y into y equals 4x minus 7. To do that, I'm going to have 5 equals 4 times 3 minus 7. Well, 4 times 3 is 12, so 5 equals 12 minus 7. Well, 12 minus 7 is 5. That is a true statement, so I have checked my answer. What I can say now, I have graphed it. I found the point on the graph. I've plugged in that ordered pair for the first equation. I've plugged in that ordered pair for the second equation. Now, After all of that work, I am ready to say 3, 5 is the solution to the system. Until you have done all of that work, you cannot tell me that you have the answer. This next example says, suppose one puppy weighs 5 pounds at birth and grows at a rate of 0.25 pounds per month over the first several months. Another puppy weighs 4 pounds at birth and grows at a rate of 0.5 pounds per month. After how many months will the puppies weigh the same amount? Notice that they have not given me a system of equations. They haven't given me 2 equations. They haven't told me to graph them, none of that. But we can write, and since we're talking about systems, it should kind of make sense, but we could write 2 different equations for this word problem. So suppose one puppy weighs 5 pounds at birth and grows at a rate of 0.25 pounds per month over the first several months. Another puppy weighs 4 pounds at birth, grows at a rate of 0.5 pounds per month. I can write an equation for each puppy. The first puppy's equation would be y equals 0.25x plus 5. 5 is where we're starting. That's how much he weighs at birth. The 0.25 represents how much he weighs per month, which means x is going to represent how many months it's been, and y is going to represent its total weight. If you notice, this is not how I want to graph an equation. I don't want a decimal for my slope. That's really, really easy to go ahead and put into a fraction though. 0.25 is the same as 1/4. So I can rewrite this equation says the same thing, but I'm going to rewrite it as y equals 1/4 x plus 5 so that I have my slope rise over run. The second puppy I can write an equation for, and it would be y equals 0.5x plus 4. Again, x would be the number of months. Y is the total weight. 4 is where he's starting. That's how much he weighed at birth. And the 0.5 represents how much he is gaining per month. Again, just like in the last equation that I wrote, I want to go ahead and rewrite 0.5 as 1/2. Those are equivalent, so I can do that. So my equation is y equals 1/2 x plus 4. Now that I have my 2 equations, I'm ready to go ahead and graph these 2 lines. The first line has a y-intercept at 5 and a slope of 1/4. And the second line has a y-intercept of 4 and a slope of 1/2. Again, just like in the last example, notice that these 2 lines are crossing on the coordinate plane right at this point, which is the point 4, 6. Just like in the last example, I cannot say that this is my answer until I have proven it, which means I've plugged in those points for both of the equations that I began with. So to check my answer, I'm going to say 6 equals 0.25 times 4 plus 5. That would be plugging in the numbers into the first equation. Well, 0.25 times 4, think about money. 0.25 would be a quarter. If you have 4 quarters, that's $1. So you have 6 equals 1 plus 5. Well, we all know that 1 plus 5 is 6. So 6 equals 6. That does work. Into the second equation, we have y equals 0.5x plus 4. When I plug in 6 and 4, I get 6 equals 0.5 times 4 plus 4. Well, 0.5 is the same as dividing by 2. Half of 4 is 2. So I have 6 equals 2 plus 4. We all know that 2 plus 4 is 6. So this is a true statement as well, which means that the 0.46 is the answer to this system of equations. Now, this 4/6 doesn't necessarily answer my question directly. It does answer my question, but I have to do something else. It says, after how many months will the puppies weigh the same amount? Well, 4/6 is my ordered pair, so which one is it? 4 months or 6 months? Remember, in both equations, I kind of made a big deal. I even wrote in both equations, x is the number of months, y is their weight. So after how many months would be the x value? It's going to take 4 months for both dogs to weigh 6 pounds. So how many months? 4. It didn't ask, but could we tell them how much they weigh? Yes, they're going to weigh 6 pounds. Both dogs are going to weigh 6 pounds after 4 months. A system can have one solution, infinite solutions, or no solutions. A system has one solution when the lines intersect. So both of the examples that we've just done, the lines intersected, I had one solution or one ordered pair that was my answer. A system has an infinite number of solutions if the equations represent the same line. So if I graphed two lines and it was the same exact line on top of each other, then that would mean that the system has an infinite number. Every point on that line works for both of the equations. And then a system has no solution when the equations are parallel lines. If you think about parallel lines, we know that parallel means that they're never going to intersect. So they're never going to have a common point or a point where they intersect. So one solution when the lines intersect, like the examples that we've just done. It has infinite solutions when you have two equations that represent the same line. And then it has no solution when the equations are parallel lines. Remember, parallel lines are going to have the same slope and a different y-intercept. This example says, what is the solution of each system? If you notice A, we have 3y equals x minus 2. And then we also have negative 6y equals negative 2x plus 4. What I need to do is I think it would be easiest if I went ahead and got these both in slope-intercept form. So I'm going to take A, and I'm going to divide everything by 3, which gives me y equals 1/3 x minus 2/3. And to solve for y in the negative 6y equals negative 2x plus 4, I need to go ahead and divide everything by negative 6. When I divide everything by negative 6, a negative 2 divided by a negative 6, remember negative divided by a negative is a positive, and 2 6 could be simplified to 1/3. A positive 4 divided by a negative 6 is going to be a negative, and 4 divided by 6, or 4 over 6, could be simplified to 2/3. Notice I have y equals 1/3 x minus 2/3, and then I also have y equals 1/3 x minus 2/3. It's pretty clear that both of these lines have the same slope and the same y-intercept. Because that is the case for A, I can say that this is the same equation, so it's going to be the same line, which means it has an infinite number of solutions. If you look at B, both of these lines both of these equations, y equals 5x minus 6 and y equals 5x plus 4, those are already in slope-intercept form. I could go ahead and graph them, but I can also just look at these equations. Notice that they have the same slope. Both have a slope of 5, but they have different y-intercepts, one at negative 6 and one at positive 4. Because that is the case, I know that these two lines are going to be parallel. When you have two lines that are parallel in a system of equations, that means that there is going to be no solution. There's no point that is going to be common for both of those lines. Today's assignment is on page 385, numbers 1 through 9, and then 10 through 36 even.